All right, let's show you how to solve this one. The first thing I notice when I'm looking at this is I see this identity over here. And so I think that's what I'm going to go for first. So here's cosine x is equal to 2. And then in here where I've got the sine, whoops, sorry, this is the identity. So the identity is 2 sine x, cosine x. And then I've got another sine x sitting out here. Okay, since these are all factors, this is nice. This gives me cosine x is equal to 4. I can see that I have two sines here, so that's going to be sine squared x, and then of course my cosine x. Now, one of the things that you have to make sure that you don't do is divide both sides by a function. That is, I do not want to divide by cosine x. That will have you lose solutions. Yeah, you never ever divide by a function. Rather, what we want to do is to get everything on one side and 0 on the other, and then we can use the 0 property to go ahead and solve. So now that I'm up to this point right here, you can see that I have the cosine x is in common. So cosine x times what gives me cosine x? Well, that's got to be 1. And then minus sine squared x. Now you're hoping for an identity in here, but there isn't one. But we've used the 0 property, so at this point I can set that cosine x equal to 0, and I can set this 1 minus 4 sine squared x also equal to 0 and solve. So as I do that, then I get sine squared x. I subtract the 1 and I divide by -4, which is going to give me 1/4 here. Well, because that's sine squared, we need to take the square root. So sine x is going to be equal to the square root of 1/4, which is 1/2. And then something very, very important here, because it's a quadratic, don't forget the plus or minus, right? Because it's a quadratic. Well, now we're giggling because we can go ahead and solve this. The cosine is 0 at pi halves and 3 pi halves. The sine is 1/2 at pi 6. Well, right here. Because I'm at pi 6, because I've got to go on each of these oh, sorry, that's terrible drawing. The sine's got to be positive in the top 2 and negative in the bottom 2. So I get pi 6, 5 pi 6, 7 pi 6, and finally 11 pi 6. I'll erase that now that you've seen that drawing. And, yep, that's about all there is to that guy.